Welcome. See, from today, last two classes, small classes, I uploaded some logical questions. Now we come to main track. Now onwards, it will be some serious questions. Academic point of view, very popular questions. See, you make a note. Connected bodies. Two bodies or two blocks are connected together. Connected by either a cable or a rigid member. I already told, if connected by a cable, now I won't tell. If connected by a cable, it can take only tension. It cannot take compression. But if connected by a rigid member, it can take compression and also tension. No problem. This all I told. See, rigid means some hard, it is not flexible. Cable is fully flexible. See, cable is fully flexible. It can take only tension. It cannot take compression. But rigid bar or hard, some what you can call is a member which will is not flexible, somewhat rigid. It can take tension and also compression. See, today one question only, even tomorrow also one question. So that I decided daily uploading one class. I will be back to here classroom after 3-4 days. So when I come back later, I will upload classes of longer duration, not just one question. Okay. Question 19, very important. Two blocks A and B are connected by a cable. Okay, I show cable red color. This question, no. See, this is the cable. Very easy to understand. See, there are two blocks here. They are connected by a cable. Then, weight of block A is 8 kilonewton. Weight and that of block B is 6 kilonewton. Coefficient of friction for contact surfaces for block A and B are 0.25 and 0.18. Means coefficient of friction here is 0.25, here it is 0.18. You should write all those. Okay, then find for what value of P the system, not one block, the entire system is on the verge of moving. See, when you apply a force here, block B will first start moving. When the B reaches on the verge of moving, then the cable will prevent it. But if you apply further force, this also will start moving. So you see here, two connected member by a cable. Now it is not preventing motion. Find what value of P the system is on the verge of moving. Or the question can be, find the minimum force required, minimum or least force required to create motion of the system. Okay. Let T be tension in the cable. Okay, now some statements are there. You should write. I will dictate. See, systematic rate. Weight of block A, 8 kilonewton, down. Weight of block B, 6 kilonewton, down. Then, T be the tension. I already told you. See, this tension, what will happen when this block moves, it will try to prevent it. But tension in the cable will move this one. See, when you apply the force, finally the tension will be, see, I told you tension is like this. See, from the contact point, I told you tension is always going away. See here. This I told thousands of times earlier class. When you consider a body, if there is a tension on the acting on the body, it is always going away. I will not explain further because earlier 3-4 classes earlier, very thoroughly I explained. Okay, now, then some statement required. See, block is on the verge of moving. Therefore, limiting friction will come. See, when the system will move to right side, so frictional force will be to left side. See, frictional force at A, limiting value. Friction force at B, limiting value. Normal reaction at A, you write here. Let RA be the normal reaction on block A and FFA limit be frictional resisting force for block A. Then write coefficient of friction between block A and surface is 0.25. See, this mu is 0.25. Given in the, if you are serious, you should write it 0.25. Therefore, frictional force for A is mu into R, or I write here the mu A into R, mu A into R, mu for A is how much? mu for A is 0.25. It is 0.25 into R. RA. Tension over. Now consider block P. Let RB be the normal reaction. P is given. Frictional force at B limiting equal to mu for contact B into RB. See here it is mu A into RA. I forgot, right? Mu A into RA. Here mu B into RB. Mu B equal to how much they told? 0.18. 0.18 into RB. 0.18 into RB. This is the complete system. Now class, how to solve? See unknowns. P, one unknown. T, second unknown. RB, third unknown. RA, fourth unknown. Four unknowns, see right here. Class, total 4 unknowns are there. So if you apply sigma fx0, sigma fy0 for the entire system, you cannot solve only 2 equations, sigma fx0, this all you should write. For the entire system, if you apply sigma fx0, sigma fy0, only 2 equations, 4 unknowns are there. So what you do is, each block consider separately. See, finally write. Therefore, consider equilibrium of each block separately. Now, one doubt will come. Which block first? It is equally important. See now, if I take block A first, see here, RA and tension, only two, see F at A is mu into R, no problem. If I take block A, RA is unknown, T is unknown, only 2 unknowns. Okay, you can apply. But if you consider block B, RB unknown, tension unknown, and P unknown. So 3 unknowns are there. So right, therefore, see, consider equilibrium of block A. Why block A first class I am telling? You always see, right here, always consider the equilibrium of that block for which unknowns are lesser. For which unknowns are lesser. This is permanent now onwards. See, now onwards permanent. I won't repeat. Whenever 2 blocks are there and when you want to consider equilibrium separately, always first consider the block for which unknowns are lesser. Right here. For block A, see, this is not unknown because it is in terms of RA. RA and T, 2 unknowns. For block P, if you consider first, P, T and RB. Oh no. Therefore, block A first. Okay. Sketch only block A. See, weight 8 kilonewton. This is RA. FF at A is 0.25 times RA, and that's all. Tension TC. Now, when you see here, when you consider block A, this arrow mark, this side. But when you consider block B, this side, see here, this is the tension for this block. This is the tension for that block. So, T, see here, this T. Okay, now start. Sigma Fy0, upward positive. You get plus RA, then here, plus RA minus 8 equal to 0. Therefore, your RA will come plus 8 kilonewton. RA will come plus 8 kilonewton. Okay, then sigma Fx0, take right side positive. What you get? Plus T minus 0.25 RA minus 0.25 RA equal to 0. Therefore, substitute RA equal to plus 8 kilonewton. Your T will come, get the value of T in kilonewton. It is 0.25 into 8 is mode 1. Okay, 0.25 into 8 is 2 kilonewton. Your T will come plus 2 kilonewton. Plus 2 kilonewton. 1 minute, I'll check the camera. Have I gone out of the camera by chance? No, plenty of space is there. Plus 2 kilonewton. Okay, now equilibrium of block A is over. Okay, now start. Now consider equilibrium. I already told you why block A first. Equilibrium of block B. Block B. See, write the sketch here. See, block B. It is like this. Weight of the block is 6 kilonewton. Then there is a normal reaction here, RB. A friction force left side of FF limit for block B equal to how much? 0.18 into RB, and there's a force P here, and there's a tension for when you do RB. See this tension, a tension force T here, but actually your T is known equal to 2 kilonewton. See, therefore, initially if you consider block B, P, T, RB, 3 unknowns. But since you first solved A with the 2 unknowns, you got T. Now if you come to block B, there are only 2 unknowns. Okay, now start. Now easily. Sigma Fy equal to 0, upward positive, plus RB minus 6 equal to 0. Therefore, your RB will come 6 kilonewton. Okay, then sigma Fx 0, take right side positive, see, then plus P minus 0.18 into RB minus 2, the tension, minus 2 equal to 0, substitute RB equal to 6 kilonewton, you get the value of P when the block is on the work job moving. P will come. So it is 0.18 into RB 6, that is 1.08, correct? Yes, plus another 2 is how much? RB is 6.18 into 6 is so much, plus another 2, 3.08 kilonewton. P will come 3.08 kilonewton is the answer. Or see, now just for your information, if this question is over now, I am winding up the class. Today I told reason because going to out of station. So when I come back, I will upload more classes, not this way. Now, question is completely over. I will tell you if this question comes in any competitive examination, how to solve. See here, how to solve if this question comes in any competitive examination. See, with actually calculator only not required. See here, what you do is, see, you put the sketch here. See, if it comes in competitive examination, mark tension T. Then see, directly. Don't waste time in competitive examination solve. Downward load of how much? 8 kilonewton. Weight, this weight is 6 kilonewton. Then see, what you do is, you are applying P here, friction force here, for this one, friction force here. Normal reaction here, I am using green color, RB, right, not required. Directly solve, see here. See, cut. See only this side. Start from A, down 8, so upward 8 kilonewton over. Then coefficient of friction is how much here? 0.2. So if it is 8 into 0.2, this force will come 8 into 0.2 is 1.6 kilonewton. 1.6 kilonewton is the frictional force. Okay. And this is 1.6, where I started now? 0.25 I think it is. Oh, it is 0.25. 0.25 R. 0.25 R is how much? Where is the calculation here? 0.25 R. I have taken tension. Yes, 0.25 R and tension. Where is 0.25? 8 kilonewton down, 8 kN up. This is 8 into 0.25 is 2 kilonewton. If it is 2 kilonewton, see, this way, then tension you got, this is 10 2, okay. Now for equilibrium, see, left side 2 kilonewton, so tension also equal to 2 kilonewton. Okay, then come here. Down 6, normal reaction up 6. No other vertical force is there. Then if this is 6, friction is 6 into 0.18, 1.08. This is friction force is 1.08. 1.08 kilonewton. 0.8 kilonewton. So now tension is how much? This tension we got how much? 2 kilonewton. See, tension 2 left side, friction 1.08 right side. So this force has to overcome friction of 1.08 and tension of 2. 2 plus 1.08 equal to 3.08 kilonewton. Directly in calculator, directly by observation, by without calculator also you can solve because round numbers are there. That is if it comes in competitive examination, but in the class we will solve systematically. Okay, that's all. One class will be missing. I decided tomorrow is Saturday, Friday one class, Saturday one class, Sunday or Monday one class. Tuesday onwards I will be back here. I will upload classes where number of questions are at least 3 or 4. Okay, next class we will meet. Thank you.